Hello everybody. Today we are starting the next chapter in computer organization, that is input output interface. A quick recap of whatever we have learned till now. All of us are now familiar with the computer block diagram, CPU organization, memory organization, and now in continuation with that we are also looking into how do we organize storage, input and output to our computer block. So when we learnt CPU and memory, so CPU and memory, one commonality between these two is they share the same technology. Both of them are in the form of chips made up of semiconductors, and as they share the type of technology which is same, they could be directly connected. They may have parallel communication, they may have same synchronous data transmission also. But what about the storage and input output devices, most popularly known as peripherals? While connecting these peripherals, uh, what points needs to be taken care of is what we will begin discussing with in today's session. Slowly, as you already know that whenever you insert any new device, you know that you need a driver program and it is being connected to an interface. So we should understand the significance of this interface. So why an interface is required? Because the peripherals are different in technology. For example, if you take a keyboard, which is an electromechanical device, or for example, if you consider a hard disk drive, which works on the principles of electromagnetics. So each of these devices transmit data in a very different format, considering the binary zeros and one for the semiconductor chips. So in a keyboard, pressing of a key is detected, converted into the code, and then transmitted as a required character. Similarly, on a hard disk drive, the data is stored in the form of alignment of magnetic dipole, N and S. For example, if you have an north pole, south pole, then probably we call it as 1, and if I change the direction, then this may be referred as 0. So working of these devices is completely different from that of a semiconductor chip, because many of these devices have human as interface. For example, the keyboard, the data is sent by a human whose speed could be hardly few characters per minute. So that means a bit may take few milliseconds to be transmitted. Considering the CPU's current rate of data transfer in terms of gigahertz, the keyboards are, even for that matter, the hard disk drives, CD drives, which requires a lot of mechanical motions, the speed of these devices, data transfer rate of these devices is also different, and the codes and formats of data is also naturally different, because as we were looking into, on a hard disk drive, the data is stored as S and N, whereas for a keyboard the data could be key released, key pressed. And similarly, if you look onto a CD, then this data is in the form of reflected light intensity, varying light intensity, that could be considered as again 0 and 1. And these devices also work in different operating modes. So most of these devices are serial in nature. For example, on a keyboard, you in sequence you send the data, which is one after the other, whereas for a processor you probably may need the data which is in parallel format. So to resolve all these issues, an interface is connected between any type of peripheral to the CPU.